Stop relying on static deep links. True interactivity in WidgetKit demands iOS 17 or later. Older versions only support deep linking through the widget URL modifier, which is passive. Actionable elements are now exclusively enabled by the AppIntents framework. To begin, you must add a dedicated widget extension target to your main application bundle using the Xcode template. The widget's data source and refresh policy are defined by either intent configuration for user configurable widgets or static configuration for fixed data. The kind identifier specified in this configuration must be absolutely unique across all widget extensions within your application group. Critically, set the minimum deployment target for this new widget extension to iOS 17. This ensures access to the necessary AppIntents and interactive application programming interfaces. This shift replaces the previous static model entirely, allowing for real-time user input like button presses and toggles directly on the home screen. Create the widget extension target by navigating to File, then New, then Target within your existing Xcode project structure. Data sharing between the main application and the widget extension is mandatory and achieved through an app group identifier. This specific app group must be enabled in the signing and capabilities settings for both the host application target and the newly created widget extension target under the app groups section. The widget extension's info.plist file controls which sizes the widget supports. Define these supported sizes, such as System Small or System Medium, using the supported family's array key. For simple, lightweight data exchange between the host app process and the widget extension process, instantiate user defaults using the shared app group identifier. The syntax is user defaults initialized with the suite name set to your specific group identifier. For example, group.your.identifier. WidgetKit schedules all future updates using a timeline, which is managed by conforming to the Timeline Provider protocol. This provider requires the implementation of three specific methods: getSnapshot, getTimeline, and getPlaceholder. The custom data structure you use to populate the timeline must conform to the Timeline Entry protocol. This conformance mandates the inclusion of a required date property. For interactive widgets, the timeline entry must also encapsulate the complete current state data needed by the SwiftUI user interface, such as a counter value or the current status of a toggle switch. The timeline entry serves as the immutable data model. This model is passed directly to the SwiftUI view responsible for rendering the widget at the scheduled time. The getTimeline method defines the refresh policy, specifying future dates and the corresponding entries, instructing the system when to update the widget. The visual presentation of the widget is defined within a standard SwiftUI view. Since iOS 17, use the Container Background modifier to ensure correct background rendering and material effects across all supported widget families. It is critical to understand the limitations. Complex animations, standard gesture recognizers, and navigation views are strictly unsupported within the restricted widget context. The view receives the current timeline entry instance as its data source and displays the information contained within that immutable model. To adapt the layout based on size, utilize the environment property initialized with the key path for widget family. This allows you to conditionally adjust content and layout to fit the current size constraints, ensuring optimal display for small, medium, or large families. Interactivity is established by linking specific UI elements to types that conform to the AppIntent protocol. Define a Swift struct that adopts the AppIntent protocol. This struct must implement the required perform method, which contains the actual logic executed when the user interacts with the element. The perform method must return an intent result to signal whether the action succeeded or failed. To pass necessary context or data from the widget view at the time of interaction, use the parameter property wrapper within the AppIntent definition. This allows you to transmit data like an item identifier or the current state value directly to the intent handler during its execution. This mechanism replaces the need for complex deep link parsing and provides a structured way to handle user input. To implement a standard actionable button, use the SwiftUI button view. Pass an instance of your defined app intent directly to the action closure using the specific intent parameter. For stateful controls, such as a toggle switch, utilize the SwiftUI toggle view. The toggle requires a binding to a Boolean state variable. The system automatically manages the interaction, invoking the associated app intent whenever the bound state changes due to user input. It is essential that the app intent immediately updates the shared data store upon successful execution of the action. This shared store could be the app group user defaults or a shared database, ensuring data consistency across processes. After an app intent successfully executes its logic and updates the underlying shared data, the widget must be explicitly reloaded to display the change on the home screen. To force this update, call widgetcenter.shared.reloadTimelines, specifying the kind identifier of your widget, for example, your widget kind, within the perform method of the app intent. This command immediately instructs the system to request a completely new timeline from your timeline provider. For persistent state management that goes beyond simple user defaults, configure robust solutions like Swift Data or Core Data. Ensure these frameworks are initialized to use the App Group Container Uniform Resource Locator. This configuration guarantees that both the host application and the widget extension process can reliably read and write to the exact same data store, maintaining synchronization. Debugging widgets requires attaching the debugger specifically to the widget extension process, which operates independently of the main application. In Xcode, select the widget extension scheme and choose the home screen as the execution target. Common runtime failures often stem from mismatched app group identifiers between the targets or incorrect timeline generation, leading to stale data presentation. During deployment, verify that the app group capability is correctly configured and provisioned in the Apple Developer Portal. Ensure this capability is included in your distribution profile. Widgets are subject to strict system-imposed memory limits. Exceeding these limits results in silent termination of the widget process without generating explicit crash logs, making memory optimization critical.